Hello guys, my name is Cliona and welcome to this video. I'm a H1 chemistry student and today I'm going to be taking you through the solution to question 8 from the 2021 chemistry Leaving Cert paper. So this question is based on organic chemistry and it focuses on conversions and reactions, and there's a quick calculation question at the end. So let's get started and let's go right into question A. Okay. So question A asks us, what is the systematic IUPAC name for Y? Okay, so IUPAC stands for International Union of Pure and Applied Chemistry. You don't need to know that, you should just kind of know what IUPAC means. When it asks for this name, okay, it basically wants the name in a word, in an English word, basically. Okay, so let's have a look at it. The first thing that I'm going to do is I'm going to draw it out because I feel like this is going to make it easier for me to see what it's going to be called, okay? So we have the C here, and then that has 3 H's attached to it, okay? And then we have another C, and that has 1 H attached to it and 1 OH attached to it, okay? And then we have another C, and we have 3 H's, okay? So as we can see, we have 3 carbon molecules, okay? Or 3 carbon atoms. So it's going to be prop, okay? Prop. It's not propane. If it was propane, it would only have carbon and hydrogen, okay? But we can see that 1 hydrogen atom has been replaced by an OH molecule, okay? And that's an indication that this is an alcohol. So it's going to end in OL, okay? So if it's propane, okay? But because it's an alcohol, what we're going to do is replace the E here with OL. Okay, but the OH molecule is attached to carbon 2. So if this is carbon 1, this is carbon 2, this is carbon 3. So it's attached to carbon 2. So our answer is 2-propanol. Okay, another way of writing this, which will get you the exact same marks, is if you say propan 2-ol. Okay, so whichever one of those you usually go with, and that will give you 3 marks for naming it propanol, 2-propanol. Okay, so now let's move on to question A part 2. So in question A part 2, it asks us to classify Y as a primary or a secondary alcohol and to justify your answer, okay? So let's just draw out Y really quickly. So we have C, 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 and then we have our H's here. So I'm just drawing propan 2-ol. Okay, so here's our OH. And then we have H, H, H. Okay, so is it a primary or a secondary alcohol? Now, I can see that it is a secondary alcohol, but why is this? It is because the carbon attached to the OH, so this carbon, which is attached to the OH, okay, that is attached to 2 other carbons because it's attached to this one here and this one here, okay? So, for example, if it was a primary alcohol, then the OH could be here because then the carbon attached to that one is only attached to 1 other carbon. Okay, so you get 3 marks here for saying that it's a secondary alcohol, and you get 3 marks for your justification, basically stating that the carbon attached to the OH is attached to 2 other carbons. Okay, so now let's move on to question B. Okay, so question B part 1 asks us to identify Z. Okay, and I've just cut this out of the question here, so you're going to have that in front of you. Okay, so let's see. We know what this is. We know that Y is propan 2-ol. Okay, but what is this? So we can see that Z is being reduced, okay, because it's gaining hydrogen. So it's being reduced in the presence of a nickel catalyst, okay? So we should know that when a ketone is reduced with hydrogen in the presence of a nickel catalyst, then you're going to get a secondary, and that's how you write secondary, alcohol. Okay? But what ketone is it going to be? Okay? So we have here propan 2-ol. I'm just going to draw that out again. So we have C, 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 So H's, the dots are just H's here. This is OH. This is H, H, H. So the dots are H's. Okay, so that is our alcohol, or secondary alcohol. Okay, so to go from the ketone to that, you're adding 2 hydrogens. Okay, so let's say you're adding this one and this one. Okay, so when it's a ketone, it doesn't have this one here and it doesn't have this one here. So what's it going to look like? It's going to look like C, C, C still. Okay, so it's, you know, it's going to be prop, okay, because there's 3 carbon atoms. It's still going to have these 3 H's, okay, but it's not going to have the hydrogen because the hydrogen is being added here. Okay, so it's just going to have a double bond to oxygen. And then on this side again, it's going to have H, H, and H. Okay, so that's propanone when there's a double bond to oxygen here in the middle. And then there's 3 carbon atoms, so it's prop. So propanone, okay? And for that, you're going to get 3 marks. And you don't need to draw out everything like I have here, and that's just for explanation purposes. So now we're going to move on to question B part 2. And in question B part 2, we're asked to draw an expanded molecular structure for Y, indicating clearly which of its bonds are formed when Z is reduced. Okay, so let's just draw Y. We've done that about 5 times so far in this video. So we have C, 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 we have H's here, H, H, we have 1 H up here, and then we have an O to a H, and then H, H, H. Okay, so that's Y. So which of these bonds are formed when Z is reduced? So we know that Z was, we didn't have this, we didn't have this, so it's a double bond here. Okay, so I'm just going to rub those out there again so we don't get confused. So which bonds are then formed? So it's clearly going to be this one because we didn't have that before. Okay, and it's going to be this OH bond because we already had a bond between C and O, so it's going to be that OH bond. But it also asks us to indicate clearly, so I'm going to write it out. So I'm going to say the O to H bond, and I'm going to say the C to H bond to which the OH is attached. C to H bond, and then you can say with the C attached to O. Okay, so for this question, you're going to get 3 marks here for drawing it out, and then you're going to get 3 marks for stating each bond clearly. Okay, so now we're going to move on to question B, part 3, which asks us, how does the geometry around the carbon atoms in Z, okay, and Z is propanone, we'll remember from the start of the question, how does that change during this reduction reaction? Okay, so we know that Z is propanone and it's reduced to propan 2-ol, okay? So the best thing that I always found to do in these kind of questions is draw out the geometry of both of the molecules, okay? So what I've drawn down here is the geometry around the central carbon atom, okay? Because that's the only place where the geometry is going to change, okay? And the answer is that the central carbon changes from triangular planar, which it was in propanone, as you can see in my diagram, to tetrahedral, which it now is in propan 2-ol, okay? So for answering this question, you're going to get 3 marks. So C part 1 asks us what type of reaction is involved in the conversion of X to Y, okay? And again, I've just cropped this image here out of the picture, or out of the exam question, okay? So it's asking us what type of reaction goes from this to this. And we can see that water is being added, okay? So it's simple enough. It's just addition because something is being added to one molecule to create another molecule, okay? So you're going to get 3 marks for that. There's another answer as well. You can say hydration, okay? So you're going to get full marks for that as well. If you say hydration, that's just the addition of water specifically. Okay, so either addition or hydration will get your 3 marks here. So let's move on to question C part 2. So now C part 2 asks us to identify another product of the reaction of X with water. Okay, so let me just draw it out. So CH3, CH, CH2. Okay, so this must be a double bond here. Okay, so another product of the reaction of X with water, okay, plus H2O. So we're adding another 2 hydrogens and another oxygen, okay? So in the reaction that we've seen, which produces propan-2-ol, okay, what's clearly happening is there's an OH going here, OH, okay, and there's a H going here, and then they're getting rid of this bond, okay? But what we're going to do is we're going to put it on the first carbon atom. So we're going to put the OH on the first carbon atom. So this is going to go OH. I'm going to take away the double bond and put in the H here. So what is this? It's going to be, so that's just propan-1-ol. Okay, so that's our answer. Propan-1-ol. So that's when the OH is attached to the first carbon atom and not the middle one. So for that, we're going to get 3 marks. So now let's move on to question D. So question D asks us to write a balanced equation for the reaction of Y with sodium. So sodium is going to be Na. Okay, what is Y? From the exam question, we know that Y is CH3, CH, OH, CH3. Okay, plus Na. Okay, so we should know that the Na is going to replace this hydrogen here, okay, because it's going to attach to the oxygen. So we're left with CH3, CH, O, Na, CH3, okay? And if you've done this experiment in school, I don't think it's a mandatory one, but hopefully you should have done it, okay? You're going to get a product of hydrogen as well, because when an alcohol, which is what Y is, that's an alcohol, reacts with sodium, you're going to get a salt, which is what this is, and hydrogen, okay? But you're not going to get H2 here, are you? Because all you're getting is what was here, okay? So you're going to get half of a H2, okay? Because hydrogen acts as H2, so it's easier to say half H2, okay? So, sorry, that should be up here, okay? So I'm going to take this away, and we're just going to make sure that this is balanced. How are we going to do that? What do we have? We have C's, we have H's, we have O's, we have NA's. Okay, now I'm going to say left-hand side, right-hand side. So how many carbon atoms do we have on the left-hand side? We have 1, 2, 3. Okay, 3. How many carbon atoms do we have on the right? 1, 2, 3. Yeah, that's all good. Okay, how many hydrogen atoms do we have on either side here? We have 1, 2, 3, 4, 5, 6, 7, 8. And on the right, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, because it's 2 multiplied by half here. How many oxygens do we have? We can see there we have 1 on either side. And how many Na sodium molecules or atoms do we have? We have 1 on either side. Okay, so this is all good. We're balanced. So for this question, you're going to get 3 for this, for the formula. And we have, or for the equation, and then you're going to get another 3 for balancing it, for ensuring that it's balanced. Okay, so now let's move on to D part 2. So this question asks us, what information does this reaction give about the OH functional group in an alcohol? Okay, so the answer is that it's acidic. But why is it acidic? Okay, because it donates a proton. It loses a proton. Because you can see that here, when you had your CH3, CH, OH, CH3, okay? and then you had plus Na. The Na bonded here with the O, and it donated a hydrogen. Okay, so then you were left with CH3, CHONA, CH3 plus whatever it was, hydrogen, half a hydrogen. Okay, so because it loses a proton, it's technically losing this. Okay, this alcohol is losing the proton, so it is a proton donor, and that means that it is acidic. So for saying that it's acidic, you get 3 marks. Okay, so now let's move on to question E. So in question E, we are told that a hand sanitizer labelled 70% VV, which is volume per volume, of isopropyl alcohol contains only water and Y. Express its concentration in terms of moles per litre of isopropyl alcohol and take the density of isopropyl alcohol as 0.8 grams per centimetre cubed. Okay, so what does it mean, first of all, that it is 70% volume per volume? Okay, that means that there is 70 centimetres cubed of Y, and Y is, I'm just going to write it up here, CH3, and this is again just from the top of the question, CH3, CHOH, CH3. So there's 70 centimetres cubed of Y per 100 centimetres cubed. Okay, now we're looking for litres. Okay, we're looking for moles per litre. So first of all, let's get this into centimetres cubed per litre. Okay, so how do we do that? It's just going to be multiply them both by 10. So that is 700 centimetres cubed per 100 or 1000 centimetres cubed, which is 1 litre. So per litre. Okay, so now we need to work with the density. So my triangle that I use is M over D multiplied by V. And this is just like the DST, distance, speed, time triangle. And how I remember this is, just from school, I've always have monkeys drink vodka. Okay, so the one you're looking for, you need to cover. So if you're looking for M, you need to multiply D by V, which is the density by the volume. If you're looking for volume, cover the V, so then you're looking for mass divided by density. Okay, so what do we have? We have the volume, which is 700 centimetres cubed, and we have the density. So we're looking for the mass, so it's going to be density multiplied by volume. So the density is 0.8 grams per centimetre cubed, okay? Multiply that by 700 centimetres cubed per litre to give us grams. Okay, and when you multiply these together, you should get 560 grams per litre. Okay, so now we have found it in grams per litre, but that's not what we want. We want to find it in moles per litre. So how do we go from grams per litre to moles per litre? We multiply it by the relative molecular mass. What is the relative molecular mass of this alcohol up here? Okay, so how do we find that? So what do we have in it? There's carbon, there's hydrogen, and there's oxygen. How many of each? Carbons, we have 1, 2, 3 carbons. Hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8. And oxygens, we just have the 1. Okay, so what is the MR of carbon? 12. Hydrogen, it's 8 or 1. And oxygen is 16. So 3 by 12 is 36. 8 by 1 is 8. And 1 by 16 is 16. So 36 plus 8 plus 16 gives us an MR of 60. So 560 grams per litre divided by the MR of 60 is going to give us 9.333, and that is moles per litre. Okay, so that is our answer. That's the concentration in moles per litre. But where are the marks going? So you're getting 3 marks for your actual answer. You're getting another 3 for finding the 700 centimetres cubed per litre into grams per litre, okay, using your monkeys drink vodka triangle, okay. And then you're getting another 3 for converting 70 centimeters cubed per 100 centimeters cubed into 700 centimeters cubed per litre. Okay, so you're getting another 3 marks up here. So now let's move on to E part 2, which is the final part of this question. Okay, so this asks us, what is the most influential type of intermolecular forces that occurs in Z? Okay, so intermolecular forces, that is the forces between molecules, not within molecules. Okay, so what is Z? We know from earlier in this question that Z is propanone, okay, which is a ketone. And we know that ketones are polar. Why are ketones polar? They're polar because of the C to the carbon to oxygen double bond, okay? So because they're polar, they're going to have dipole-dipole forces. And that will give you 3 marks. Okay guys, so that is all for this question. Thank you for listening, and I hope that it has cleared up any questions you may have had based on the solution to this question, and I'll see you all in the next video.